Okay, so I'm going to look at some metals and non-metals questions. This is question number one. Metals make up about 80% of the periodic table, aluminium and magnesium, so in both examples of metals. So it's describing where the metals and non-metals are found. Very generally, the metals are found to the left-hand side, generally of obviously the ziggy-zaggy line which separates the two, so the left-hand side of the line, if you've got a periodic table with the line on it. And non-metals are generally found to the right-hand side in a more situation to the right-hand side of the zigzag. Obviously, there's a general diagonal situation, so left-hand side more to the bottom half, a right-hand side more to the top half of the periodic table. But as I say, most of the periodic table is metals anyway. So question 1.2 then, which of the following statements is true? We'll go through these in turn. Elements react to form negative ions are metals. Okay, so if we are looking at a metal generally to the left-hand side of the periodic table, for example in group 1 or group 2, that's going to have 1 or 2 outer electrons. When they react, they're going to lose those electrons. Electrons, as we know, are negatively charged. So if something is going to lose a negative charge, it isn't going to retain a negative charge in its ion. So it isn't that one. As a result, what we've kind of just said is that they are going to form positive ions. So that's possibly the correct answer. We'll just make sure the final two are wrong there as well. So elements react to form positive ions. We know that's true for a metal, not a non-metal, so that's obviously the wrong way around. Non-metals would form negative ions, and elements that do not form ions, obviously if we're not forming an ion, that's the group 8 noble gases. So the correct answer was the second one, as we thought. So if we look at the third question then, one physical property that magnesium and aluminium have in common. So this is any general property of a metal which is useful, so conduction. Generally that can be of heat and or electricity, both used movement of the delocalized electrons to do so, but conduction. Some more physical things, such as it would be malleable, so you can bend it, shape it, and things like that. It would generally have, aluminium and magnesium do, they'd have a high melting point and boiling point, relatively, so high boiling point, melting point as well. And generally metals in their kind of physical situation, they're strong. You can make strong substances out of them once you've shaped them into the shapes that you need. So why do magnesium and aluminium react in a similar way? Now, this is not because of groups necessarily. A lot of the questions we've looked at have looked at why they react similar because they're in the same group. These aren't in the same group. Magnesium's in group 2. Aluminium is in group 3. So they're not in the same group. However, magnesium's got 2 outer electrons. Aluminium's got 3 outer electrons. Both need to lose outer electrons. Okay, so they're going to do it. So both need to lose outer electrons. Obviously different numbers, but they're going to react similarly in the fact that they're both going to lose electrons, and they're also going to form positive ions as a result of that reaction.